we have to find the eigenvalues and eigenvectors of this matrix. The characteristic equation is determinant 1 minus lambda minus 1, 2 minus 1 minus lambda equal 0. If we solve this determinant, minus 1 minus lambda square plus 2 equals to 0. So lambda square is 1, lambda is plus minus I. Both the eigenvalues are complex. Let us take alpha x1, x2 is the eigenvector for lambda equals to I. We have A alpha equal I alpha, where A is 1 minus 1, 2 minus 1. So 1 minus 1, 2 minus 1, and alpha is x1, x2, then I x1, I x2. Now let us solve this matrix equation. x1 minus x2 is I x1. So 1 minus I x1 minus x2 equals to 0. And 2x1 minus x2 is I x2. 2x1 minus 1 plus I x2 equal 0. Now let us solve these two equations. One minus I x1 minus x2 equals 0, and 2x1 minus 1 plus I x2 equals to 0. We have to solve these two equations. If we multiply the first equation with 1 plus I, then we have 2x1 minus 1 plus I x2 equals 0, and second equation is 2x1 minus 1 plus I x2 equals 0. Now you see both the equations are same. So let us find x1 in terms of x2. So here from this equation 1, so this is equation 1 and this is 2. So from equation 1, 1 minus I x1 is x2. Therefore, the eigenvectors for eigenvalue I is x1, 1 minus I x1, where x1 belongs to R, the set of real numbers. Similarly, we can find the eigenvector for the eigenvalue minus I. Let beta equals to y1, y2 is the eigenvector for eigenvalue lambda is minus I. Then A beta equals to I minus I beta. So we have 1 minus 1, 2 minus 1, y1, y2 minus I y1 minus I y2. Let us solve this matrix equation. y1 minus y2 is minus I y1. So 1 plus I y1 minus y2 equals 0. 2y1 minus y2 equal minus I y2. 2y1 minus 1 minus I y2 equals to 0. One plus I y1 minus y2 equals 0 and 2y1 minus 1 minus I y2 equals to 0. Now let us take this equation as 1, this one as 2. Then let us multiply by 1 minus I. Then we will have 2y1 minus 1 minus I y2 equals 0 and 2y1 minus 1 minus I y2 equals 0. So two equations are similar. Therefore from equation 1 we can write 1 plus I y1 is y2. Therefore, the eigenvector for the eigenvalue minus I is y1, 1 plus I y1, where y1 belongs to the set of real numbers. So, for eigenvalue I, the eigenvector is x, 1 minus I x. X belongs to R. For eigenvalue minus I, the eigenvector is x, 1 plus I x. X belongs to R. So for different values of x, we will get different eigenvectors. Therefore, there are multiple eigenvectors.
For admission and course-related enquiry, please visit college website http://www.svist.org/